Hi, everyone, and welcome to this new episode of The Lockdown. Today, I am joined by Dr. Lisa Barrett Feldman, who is really a famous neuroscientist. And by that, I really mean both parts of the term. She is one of the most widely cited and published researchers in the field of neuroscience, with a lot of groundbreaking work around the neuroscience of emotions and our understanding of kind of how the brain processes and manages emotions, but also a public intellectual with a few TED Talks, one of them with over 6 million views, and two popular or kind of more general audience books that she wrote more recently on emotions and on 7.5 lessons about the brain, which really made me very excited to speak to her today. So we're going to talk about the latest book and a little bit on her research. And I know that you will find this very, very interesting at a time and point where everyone talks about the brain without necessarily understanding it. And Lisa has an amazing ability to tell stories that are both accurate and engaging about the brain. So with that, Lisa, thank you so much for making time today.
Oh, it's my pleasure. Thanks so much for having me on your podcast.
Okay, so you spend quite a bit of time not just on research, but also educating wider audiences about the brain, especially challenging or debunking misconceptions. Why? Why do you bother? What drives you to do this?
Well, it's I'll try to give you the short version of the story. Um, I never thought that this was something I would do. And in fact, maybe 10 years ago, a lot of scientists in the circles that I travel in started writing popular books. And I just never felt like it was my forte. I never felt like I was very good at it. And I'm really happy being in the lab with my head stuck in data, analysis and stuff. So, but then a young journalist came to me and she was really interested in doing a piece for a magazine. It was actually Boston Magazine. She spent about 6 months interviewing me. It was her first big piece that she ever had accepted. And then like in the 11th hour, her editor said, well, why do we, who cares that everyone's using the wrong scientific ideas about emotion? Like, why does it matter? And my initial reaction was, really kind of defensive. Like, I was like, oh, please, it's science. Everyone should just be interested in science, and then, she would come back and say, well, he's really asking. And, and I'd be like, look, does anybody ask that, why does anybody care about like discovering the Higgs boson or anything in, cosmology? No one asks those questions. They're just interested. Let's just be interested. Anyways, we had this kind of dance going back and forth. And then she came to me at a certain point and said, if I don't come up with like a really good reason, he's not going to publish this. And I felt really responsible because she's young. This was like her first, big piece that she was doing. She spent all this time talking to me and I felt kind of responsible to her. So I thought, okay, fine, I'll just sit down and think about it for 5 minutes. And when I sat down and I thought about it for 5 minutes, I realized actually there are a number of reasons why people should really care. In fact, some people lose their lives. And this is not an exaggeration in any way, because they or their physicians are using the wrong ideas about emotion that are very popular, but have no validity and they're really no basis in science. And at the same time, I think, we started entering a period where, science has never really been respected in popular discourse in the United States to the same extent as in other countries. That's my experience. But what I found was, first of all, that it's really hard to be an informed citizen right now anywhere if you don't know anything, if you are unfamiliar with how science works. What are its strengths? What are its pitfalls? What do we know? What don't we know? About climate change, about how viruses work or whatever. You really need to have kind of a basic working knowledge. And I also found that people are really, I don't know who it is who makes the decisions about how much science is on the front page of newspapers and in magazines, but the average everyday person is really interested. I still am receiving, now not, well, I mean, now there's the new book, but with How Emotions Are Made, I still, which is my first book, I'm still receiving, I would say on the average of 5 emails a day. It goes up or down, but I, initially was receiving hundreds a day, but the book's been out for 4 years and I'm still receiving emails. So with questions and, so I think people are really interested, and it's been a long journey for me, but I've come to realize that it's my responsibility to do this to the best of my ability. It's not easy, right? It's not easy for me. I'm an academic writer, and writing for the public is a big challenge. And so I also kind of like that too. I feel like I like to challenge myself and try things that, are hard or that I think I can't do. And then,
Yeah. That, everyone talks about storytelling, but you really are a master at it, and you tell stories about the brain that are captivating from the very beginning, right? So I have my iPad here with some notes. Lesson number 6, which is brains make more than one kind of mind, starts with, when people from the island of Bali in Indonesia are afraid, they fall asleep.
I know,
And,
isn't that cool
boom.
though? I mean,
exactly. And then you go on to explain, different reactions to fear, etc. Did that come naturally to you, or did you work on it and perfect it? I know you're also a voracious reader. Can't remember if on your website or somewhere you actually have the books that you're reading on, and they're very wide ranging. That probably contribute to it because you can draw from different kind of sciences and fields. But how do you get to be such a great storyteller?
Well, thank you. First of all, I very much appreciate that comment. And, I work hard at it, but I think I have a secret weapon, and that is my husband. So one of the things that we realized early on, like we'd go to dinner parties, or, when we all used to go to dinner parties.
Yeah.
And someone would ask a question, and then I would, they'd ask a question about my work, and I'd start talking, and basically I'd be telling a story, and people would, come away really, they were like captivated. And at the end of the evening, I'd say to my husband, "Oh, I feel like I totally monopolized that conversation," and I would be like, nervous about it, and he'd be like, "What are you talking about? You just had those people, like they were totally interested in everything you said." So when I decided to really dip my toe into this arena, and before I even wrote a book, I started writing pieces for the New York Times. The first thing that I would do, and it still is the first thing I always do, is I just sit my husband down in a chair in my office and I talk to him about what it is I want to say. And so I don't just sit down and write. That's not me. I talk to him out loud. He listens and asks questions. Then I transcribe what I've said, and then I try to manipulate it into an outline. And then I usually try to look for a hook that's going to be surprising to people or really interesting to people, or something that I myself, even though I'm a neuroscientist and been doing this for a while now, I think, geez, I can't, like, this is so cool. I just totally can't believe this, because that's the kind of hook that grabs people's attention, and I think gives people a little patience to sort of to come along with you, maybe through a little bit of the mucky details of things. Yeah. So for example, I just am writing a piece now about simple feelings that we have that come from the way that our brain controls our body. And the opening line is about Spider-Man. It's about having like a spider sense, and it's fun, and it's like an interesting way to sort of grab people that maybe you have this little superpower that you didn't really know that you had. It can also be kind of not a liability, but it's it's a little tricky to manage the superpower, just as all superheroes find out, right? That it's a double-edged sword. So I'm always looking for really interesting things that will just like grab people's attention.
Yeah, yeah, yeah. I think, yeah. Well, I can see the one specific tactic or approach of starting the chapter or each section with a catchy and captivating line. Here's another one from the half lesson chapter, which is "Your brain is not for thinking." Great subtitle, of course. That's probably the lesson that everyone talks about the most, or that grabs people's attention the most. It starts with the following sentence: "Once upon a time, the earth was ruled by creatures without brains." This is not a political statement, just a biological one.
I know you're not supposed to laugh at your own jokes, but I'm sorry.
No, but they're funny. They're funny.
I'm still really pleased with myself about that one.
Well, one can imagine what was happening in the world at the time of writing this, and it could have been at several points in time. But anyway, so that's mostly kind of questions on style. Let's talk a little bit about content. What are some of the most compelling and persisting myths that people hold about the brain?
Well, I don't even know where to start. There are so many. I mean, I wanted to keep the book short, and I wanted it to be, I wanted there to be a set of little essays. I wanted to keep it really short. I wanted, people to be able to read it on the subway or in the bathtub, or like my husband says, it's the first neuroscience beach read. So I only picked a couple that I thought were really pervasive. And they have to do, all of them really, what they all have in common is scientists and just the average person's tendency to use their own experience as a guide for how the brain works. So, if you look at modern neuroscience and you look at the concepts, the ideas that organize that research, it's things like emotion, memory, perception, action. They're our very Western experiences, because these are not experiences. Not everyone in the world divides up their mental life into these little categories. Other countries and cultures use other categories, but we use these categories. And so there's a tendency to go looking into the brain for these categories. So one persistent myth is that your brain is a battleground between your inner beast, like your urges and instincts and emotions, which are sort of deep in some ancient part of your brain, and your rational self, which is in some more evolved part of your brain. And this idea that these two parts, this old part and this new part, are like battling it out for control of your behavior for your whole life. And when your rationality wins, you are moral and healthy. And when your inner urge, your inner beast wins, you are either sick, like you're mentally ill if you can't control your inner beast by rationality, or you are morally wanting if you don't, but you could, but you don't. And it's a great story, and it's a story that makes sense to us because it's actually a received wisdom that we have from ancient Greece, where we get a lot of our ideas still about how human minds work. It's a story that's embedded in the law. It's really enshrined in the law, not just in the US, but I mean in the UK, which is where the US gets some of its legal ideas from, and in many Western countries. It's in economics. It used to be that the rational economic man, right? The rational side was seen as the victor, and now it's the irrational side. But there's still this idea that humans are, we're like, our rationality is like icing on an already baked cake. Like our brain, we just have this like ancient, already baked brain, and then we just put rationality on top in our cerebral cortex. And it's a great story. It's just not true. And what's really interesting to me is that the evidence that this is not really how the brain evolved, and it's not really how the brain functions, has really been around for, well, at least from on the question of evolution, it's been around since the 1960s, since scientists started using molecular genetics and other ways of peering deep into the molecular functioning of cells to look at genes and how those genes work to produce the proteins that make up your body and your brain. So that evidence has been around for a really long time. And right when the evidence was starting to really come together in the 70s, that's when Carl Sagan published this wildly popular book, The Dragons of Eden, which won a Pulitzer Prize, and is a great book, except for this part about, the what's called the triune brain, that you have a brain that's built in layers, with a lizard brain for instincts and a limbic system, including a little nugget in your temporal lobe called the amygdala for emotion, and then your cerebral cortex on top for rationality. It's just a myth, and it's a myth that's really, really hard to wrench away from people. Mm-hmm. I think another myth is just, again, stems from our own values, our own experiences and our own values, and that is that rationality, means the absence of emotion or the absence of feeling. That also is just that's a biological impossibility given how your brain is wired. So, and just, the idea that the most miraculous thing that your brain can do is think is actually not true. So there's a really good description of this in a book by Stuart Firestein at Columbia, actually, in biology. He has these two little books, which I love, called, one's called Ignorance and the other's called Failure. And I think the example I'm about to give is in Ignorance. They're tiny little books, and they're really all about the value of not knowing things in science. And he tells this story, which is absolutely true, that scientists, when they wanted to understand and learn how the brain works, they picked the visual system to try to really understand the inner workings of the neurons in the visual system, because our visual system looks very, very well developed in the brain compared to other animals. And of course, vision is really important to humans, as is thinking. And so the assumption is, if you can understand how the visual system works, then you understand the basic properties of how the brain works. That is so far, as my daughter would say, that's not even wrong. That's just like so far from the truth. And so, it's kind of hard to figure out how the brain sees, but I think that scientists have done a pretty good job of figuring out some pretty basic things. However, what about moving your hand to pick up a glass and bring it to your face and take a drink? That turns out to be an unsolved problem. Really, really hard. Like, how does your brain control your body to move your limbs, and what's going on inside your body in all those complicated systems to allow that to happen? That turns out to be really, really hard and an unsolved problem. And that's something we have in common with all other vertebrates. So the hardest things that our brain does are things that we share with every other vertebrate on this planet.
Yeah.
And I think that's again, it's a myth that comes from our belief in our own specialness.
Yeah. I heard you in another interview say something along the lines of, we are not the pinnacle of anything except in our own minds, which basically sums up the example you just gave. I think we have a tendency to, well, look for things that make us special, unique, or more advanced, really.
Yeah, I mean, you know, look, there's no question we're a really cool species, right? I mean, we do like really miraculous things, and that's what lesson 7 is all about. And our brains are different in subtle ways from other vertebrates, for sure. But it's important to understand that other animals, first of all, some of the most important things that our brain does, some of the most complex and difficult to understand things that our brain does, are the things that our brains have in common with other vertebrates. And also, other animal brains are pretty cool in their own right. And some animals can do some pretty miraculous things that we cannot do, and that we endow in our superheroes because we're so impressed with them. So yeah, we can do some amazing things, but so can other animals. And that's the beauty of natural selection, is that, you know, as a concept, it's shaping an animal to the animal's niche, the part of the environment that is important to the animal's survival. And there's, again, another little book by Henry Gee, who's a paleontologist, who's an editor at Nature. It's called The Accidental Species. And it's this small book about evolution. And he basically makes the point, you know, evolution did not aim itself towards us. It's, you know, and so again, you just have to be, as a scientist, you always have to be vigilant for how your own values and beliefs and inferences can creep into the science that you do. Mm-hmm. That's something that's, you know, really, really, really important. It's as important as learning fancy schmancy, you know, machine learning algorithms for analyzing data.
Yeah, what is it? The kind of the analogy of the drunk guy who looks for his keys under the lamppost, not because they're there, but that's because he can see there, right? So confirmation bias exists among scientists as well. So should we think of humans or the human species as a work in progress?
Well, every species is a work. Mm-hmm. But natural selection ensures that every species is a work in progress. You know, one of the examples I like to give is, you know, do you have a beer? Are you a beer drinker?
I am, yes, absolutely. Yeah. We can get very technical on the subject if you like.
Okay, well, but you probably know this, but beer making companies have a really hard time stabilizing their yeast, mm-hmm. right? Because they evolve, like their genes change, and so the taste of the beer will change, and so they have to fix it, which is hard. So, you know, something I talk about in How Emotions Are Made is about why is it that we tend towards, at least in this culture, and I would say really in certain ways, in it's a property of the brain actually, that we essentialize. We tend to think that things that look the same or sound the same or taste the same, all, you know, so everything that, you know, fits, that's similar and belongs to a category, shares some kind of you know, deep, immutable, common thing or essence that makes the thing what it is. And so before Darwin, for example, this was well exemplified by a guy named Lamarck, who also talked about evolution. And his idea about evolution was, you evolved a characteristic, so you develop a characteristic, and then you just then you have it. It's like it's your essence, and you pass that along to your offspring. And that's how a lot of people think about genes, that, you know, you have a characteristic that's rooted in, you know, genes, and then you just pass that along unchanging, you know, through the, you know, through the generations. What's really remarkable, though, actually, is that when you find genes that are stable across generations, that's the remarkable thing. Because genes just will, by virtue of the way that cells reproduce, you see there's always a drift towards mutation. So, for example, we have genes that we share with flies and other invertebrates, which means, and these genes are not changed too much. And they're the genes for, they're like the genes that sort of direct, they're like a GPS system for setting up an embryo. And so, you know, why is it that the head is always at the front of an animal? And, you know, like, why do we have these segments? And not all animals have them, but most animals do, even invertebrates. So why is the tail at the bottom and the head at the front? That's because we have a set of genes. They're called Hox genes. These genes are ancient, 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 and they are pretty much the same. So that's the remarkable thing. The remarkable thing is not that there's change, or that we're that we're all a work in progress, both individually, I would say, and as a species, but that some things are stable across millions of years. That's remarkable, and that's the question that has to be answered.
That's the unusual thing, right? A bit like finding a fashion item that hasn't changed since the 40s or 50s, and it's still being worn. And it's like, wow, it looks kind of current.
Yeah, I mean, here's another example of that, which I find really interesting. So a lot of scientists for many years asked themselves, why can a part of the brain called the hippocampus in a human and in a primate, why can it produce new cells? Like, for most of your brain in human, most of your brain, Thomas, your brain can't grow new neurons, right? Except for one or two places in your brain. So the neurons you have, you got to hold on to, and you've got to take care of them, because if you lose them, you're in really big trouble. And so scientists were asking, like, gee, why can the hippocampus birth new neurons? Like, why? Totally wrong question, because it turns out most animals' brains can actually produce new neurons everywhere all the time.
Yeah.
We've lost that ability.
Yeah.
The big question is not why can the hippocampus produce new neurons? The big question is, why can the cerebral cortex not?
Yeah. Yeah.
That is the interesting question.
Yeah, well, we can have a different section on kind of neuron preservation strategies, which I badly need. But on that note, you know, what is your take, or what are your views on the kind of use it or lose it sort of brain training approaches? You know, there's been a lot of activity there, I would say, in the last decade or so. Is there any evidence to that? Maintaining,
yeah, I think, well, yeah, there is, but there's a big caveat. And so your brain is a use it or lose it organ for sure. Yeah, there's just no question that that's true. But I think that the rub is in, what does it mean to use it? Like, what does using your brain really mean? I think the evidence shows pretty clearly, if you exercise on a regular basis, and I don't just mean go for a stroll, I mean get your heart rate up to the point where you feel crappy, like in the middle of, you know, I don't know about you. I mean, I exercise every day. I don't love it. I hope my trainer's not listening to this. I don't love it, but I really appreciate how I feel later. Afterwards. So I think of it as a good investment of energy. And frankly, you know, discomfort, because I'm not a big fan. I don't love doing it while I'm doing it. And about, 20 minutes into it, I'm thinking, oh my God, I just want this to stop. And there are reasons for that. But my point is that exercise actually is a great investment to keep your brain healthy, and has an effect on the parts of the brain that not only control your body, but also help you attend to things better, help you remember things better, maintain the speed with which you can think, and so on. And I would say there's some evidence that things which in general are hard for you to do, that involve learning something that gives you that little bit of yuck feeling, like this is so hard, that's probably good for you. So, Sudoku games or whatever, little puzzles and stuff, is that good for you? There's no evidence actually that kind of stuff is good for you. But, learning to paint, learning to knit, learning to play an instrument, those things are probably really good for you. It's just that they have to be something that's effortful, that requires sustained investment, and that feel a little hard.
Yeah. So in a way, there's an analogy between activities that make you think which is probably not Sudoku or keeping up with the Kardashians,
Right.
and activities that exhaust you physically as well, because your heartbeat goes up, and so the metabolic kind of churn or burn or demands should be high, both from a thinking perspective
Yeah.
and a physical. Let's change subjects a little bit and talk about emotions. How good are people at reading others' emotions? And do you have any confidence in technologies doing a better job than humans? Let's say AI or algorithms that scrape video interviews or equivalent, which is an area where there's, again, a lot of activity or discussion right now.
Yeah, I would say it's the wrong question, because we don't read each other, because emotions aren't things to be read like words on a page. And so your brain is constantly making inferences about the meaning of sense data that it is receiving from the world, including things like my facial movements, my body posture, my vocalizations. And your brain is making inferences about the meaning of those things, these movements, the sense data, in the context that we're in, including your own physical state. Like for your brain carries around its own context all the time, which is the state of your body. Your brain is constantly modeling your body, what's going on inside your body. And that process influences what you see and what you hear and what you taste, and also how you guess at the meaning of those sounds and tastes and sights and so on. So your brain is not reading anything, it's guessing. And sure, some people are better at guessing than others, and some people are good senders. So that is, they send a lot of information, they're sending a lot of cues, others less so. And then there are contextual differences, right, too. So you and I, for example, don't know each other very well. We just met, right? So we're probably using stereotypes, just like general beliefs about what someone does in a Zoom interview. Although you mentioned earlier that you had watched a couple of videos that I had done and maybe heard some podcasts. So you're a little more familiar with my, the way that I might speak, or the way that I might move my face or my body. My point being that we are pattern learners. The human brain's a pattern learner. Actually, all brains are pattern learners. And so as you and I get to know each other better, we move away. Our guesses are not so much anchored in stereotypes of general beliefs about what people do, but become much more tailored to each other's, the probability distributions of our own actions, right? So for example, my husband, when he scowls, when he is confused, or when he's thinking really hard about something you said, his face takes on a full facial scowl that is the stereotype of anger expressions in the United States. But he's not angry. He's really concentrating hard. And in fact, if you look at the data, in large scale cultures, people scowl when they're angry about 30% of the time. That's more than chance. That gets you a really good publication, in a good journal.
Yeah.
But that means 70% of the time, people are doing something else with their face when they're angry. That's meaningful, right? So, and you can pick any emotion category and any proposed expression that's supposed to be universal for that category, and the findings are pretty much the same. So humans are actually, given how complicated the job is the task is that we have before us, we actually in general don't do too badly, I would say. There are some catastrophic errors, but we have a rich milieu of signals that our brains are using, including words, right? And also the temporal context. So the brain is doing this very complicated guessing, very complicated inference, using a lot of information, not just one or two signals. And so your question about AI scraping information is a hard one to answer, because you could answer the question in general, would AI be better, or currently is AI better? And, currently what AI, again, how much do you embed your own assumptions in the algorithms that you build, or in the data sets that you train those algorithms on? So you can have the fanciest, schmanciest algorithm, and you can have the biggest data set, millions and millions and millions of videos from YouTube, let's say, which is, YouTube is curated. Let's just leave that issue aside. You can have all of that, but if you sampled those millions of videos in a particular way that you are unaware, that you're, by some guiding inference that you're unaware of, or if you had, humans annotate those videos in ways that are very ethnocentric, and you don't realize that you did that, then it really doesn't matter, how fancy your algorithm is, because your algorithm is going to be not generalizable to the real world. So I would say right now, humans do a much better job than any AI that exists, as far as I know. I could be wrong. I mean, maybe there's some company somewhere that's actually finally seen the light, but it is possible, if companies or if scientists took these issues really, really seriously, it is possible, and that that AI could do a better job. And I will say that there are some, like right now, we've done a series of studies where we used common sense categories like anger, sad, fear, disgust, these that are Western categories, to guide, like to do supervised machine learning, supervised classification of data, okay? And then we used unsupervised methods. And in our unsupervised methods, we find really reliable we can discover reliable categories in our data. And sometimes they're more reliable than the ones that we verify with the supervised learning, but they don't look anything alike. Like they don't look anything alike at all. So there are definitely, even when you're only measuring 5 or 10 signals from someone, there are definitely recurring patterns in those signals that do not correspond to our, the common sense categories that we organize our inferences by. And sometimes hidden in those regularities are opportunities for real discovery, I would say. So it is possible to learn things from AI, using AI as a context for discovery. In science, we make this distinction between the context of discovery and the context of verification. AI doesn't tell you something that's true. It doesn't tell you what's true, but it can tell you something that is consistent, and that's good fodder for a hypothesis. So it's a good opportunity for discovery. But the way that currently the companies are doing emotion reading, is, as far as I know, and I've written about this, I've talked about this to some extent, fraught with real problems, not because of the technology itself, but because of the embedded assumptions that are, and there's a real missed opportunity there, because if someone were to use that technology differently, and there are some people who are starting to push in that direction, then you would have an incredibly powerful scientific tool.
One of the problems with the issue you highlighted about how we basically, the human mind makes inferences based on limited and noisy signals and influenced by the realm, and all of that, is that we still make inferences, right? So whether it's a job interview or performance evaluation, and I think mostly we're good at remaining unaware of our mistakes because we hide them later. And, so I might think that I'm very funny and you're really bored, but I continue to think that you find me very funny and so on. So a lot of companies are doing things like unconscious bias training and trying to debias people. Do you have any views on this, or?
I have very strong views on this, and that are mainly guided by science. So
yep.
I'm going to try to say this in as careful a way as possible.
Okay.
Because I think that there's a lot of misunderstanding. So there definitely is implicit bias. There just is. And we don't need laboratory experiments to show us this. The statistics just show us that there is structural bias in the way that our culture is set up and in our practices. Okay? Children with brown skin are not treated the same way at the doctors as children with light skin. They don't get the same medicine. They don't get the same painkillers. It's a travesty. I'm not saying that as a scientist. I'm just saying that as a mother and a person, okay? So does implicit bias exist? Yes, it does, for sure.
And sorry, we know those biases are implicit rather than explicit as well, because we know there's.
Well, I think some of them are explicit. Some of them are explicit. I mean, sometimes people are, but I think in the case like the example that I'm giving you here, I think physicians, even physicians. So physicians used to be taught, believe it or not, that people with brown skin actually had a tolerance for like pain. That somehow, and I'm not using the racial category black, white, because that's actually those are social categories. I'm talking about the amount of melanin in your skin that gives it a tone, that somehow was biologically related to higher pain tolerance. Not true. Okay, not true. But even people who don't believe that anymore still underprescribe.
Yeah. So that's
they're not even aware. They're not even aware they're underprescribing. Look, there may be some physicians who are prejudiced and have biases, and they wear those biases very clearly in their own minds. But I think a lot of don't, and they still are doing it. I'm not saying everyone's doing it. I'm just saying there are studies which show that physicians do it, and it's not just physicians, right? So you can look across the board at any domain in which any of this has ever been studied, and we don't treat people the same depending on the amount of melanin in their skin, which, by the way, race may not have a biological basis, but your skin tone does. And it has to do with the kind of tug of war between two vitamins in relation to where you live relative to the equator and how much sun you get. But that's like a whole other story. Okay, so let's just assume that implicit bias exists in various domains in life. The question then is, do the tests that people give that you can take, do they measure this implicit bias? And the answer is not so much, a little bit.
You mean like IIT tests?
Yeah, I mean like the IIT. And I should say, I have the most respect for Mazavin Banaji and Tony Greenwald. And I think they've done a remarkable job at a research program. But I think by their own admission, by their own meta-analyses, they show that what they're studying are implicit associations. So when basically your mind is an association generator, we sometimes talk about that in terms of memory or prediction, or, we have all these ways of talking about it, but basically your brain is constantly generating associations based on what's going on now. It's making predictions about what's likely to happen next. And those are associations. And so the tests that are around, first of all, are only testing your associations in a given moment, in a given context. They're not discussed that way. They're not discussed as these highly contextual, highly temporally variable things, but they are. And they predict bias a little bit, consistently, a little bit, not a lot, but a little bit, more than chance in a lot of cases, but still not a lot. So, do bias training program, debiasing training programs, do they work? many of them don't work. There's some really nice research by a researcher named Patricia Devine at the University of Wisconsin, who does work on people's motivation to change. And that seems to predict how well some training programs work. Actually, the people who are really motivated to change actually do change more than the ones who are less motivated. So that's an interesting.
So in a way, the programs work most for those who need it the least.
Maybe. But I would say that there are some really basic things that nobody's really taking into account. And that really gets back to this issue that you asked me at the beginning, like why do you talk to the public? And you know, why is it important that the public understand how the brain works? And because there are some pretty interesting things that you discover about how debiasing programs might work, like which ones might work better based on understanding a little bit about just how the brain works, right? So, for example, there's all this research showing that if you show people images of brown faces, right, that people have an increased activity in their amygdala, and so then they tell all kinds of stories about, oh, you know, so this is an example of implicit bias. This is racism. You're afraid. You're, you know, blah. You know what? If I show you a scene that you've never seen before, if I show you a fork that you've never seen before, if I show you anything that you've never seen before, or that you are seen infrequently, you will show an increase in amygdala activity. Because the amygdala is not the home of fear. It's not the home of aggression. It's not the home of emotion. It's actually a cluster of nuclei that that all do different things. But if you were going to sum them up in a way, what you would say is that they're like a signal to other parts of the brain about whether the thing that you're faced with, whether it's novel, ambiguous, and whether you can predict what it is and what you need to do next to deal with it. So if you grow up in an environment where you are only surrounded by people who are like you, and you are perceptually unfamiliar with people who don't look like you, don't sound like you, don't smell like you, don't eat the same food that you eat, you will have an increase in arousal around those people because they are unfamiliar, because your brain can't predict as well. And we could sort of probe more deeply into that if we had a couple of hours, but but it's really important to understand that just mere exposure in a meaningful way, where you meaningfully interact with people who are different from you, can reduce bias. And there is some evidence to show that this is the case, but there's also real world experiences that we can see work that should be really good evidence for more precise scientific testing in the lab.
Yeah, that's a kind of a Shawshank Redemption, mere exposure, right? Or American History X, if you want to take it.
Yeah, I mean, it's not really mere exposure, right? It's like it's like meaningful. That's what I said. But it's like meaningful exposure. But repetition breeds familiarity in the brain.
Yeah.
And that's a really, it turns out to be an incredibly powerful, metabolically consequential thing for a brain.
Yeah, I mean, and I know that, you know, you also advise and appeared as kind of an expert witness and kind of some forensic, but there are real issues surely of pretending to use or assuming to use science or neuroscience to label someone biased or more biased or unconsciously biased when the diagnostic tool doesn't work. And when there are a lot of consequences, you know, I mean, let's take the example you mentioned. It's like, yeah, you know, your amygdala fires, so boom. Suddenly I think of myself as a cruel, mean, bad individual. I didn't have a bias, etc. So surely we should raise awareness
We
on
absolutely
this.
should, but I also need to say that we just need to strip away the word, the sort of ugliness from the word bias, because you have a bias about I mean, your brain is predicting. So you always have a bias about everything. I mean, it's just the word bias when we apply it to people has a specific meaning. I mean, I'll just say this, if you are a person like me who is very light skinned, you walk through your day unencumbered by obstacles that other people face all the time. Your day is smooth compared to other people who are, a person of color or a visible minority in some other way. Your path is smoother, no matter how hard your path is, no matter how much you suffer in a day. There are ways in which your path is eased by the absence of obstacles. And if you are unaware of that, as I am a large part of the time, because I'm not thinking about it all the time, that is a form of bias. Bias is not just the presence of things, it's also the absence of things. And so I think it would be good if we could, rebrand what's happening, because there's always, with bias, there's always this, colloquially, there's always this implication of intent, which from a neuroscience standpoint, and even from a statistical standpoint, think about signal detection theory. They talk about sensitivity and bias, but bias, they don't mean you nasty prejudiced person. They mean, statistically speaking, you're more likely to choose X than Y, more than 50% of the time, or more than whatever the base rate is of X versus Y. It just means that you have a tendency to do something or to not do something. That's all it really means. And if we were to really start there, we might have a better conversation,
So you could call them assumptions, perhaps, or kind of bias is a lot of. What term would you use? I mean, is it?
I don't know. I'd have to really think about that, because one of the problems with using terms is that they morph their meaning, right? So just think about Negro, and then colored, and then Black, and then African American, and now we're back to Black again. And think about, you can pick any label or set of labels, and they started out as singular in the English language, and then it became plural, and now it's back to to singular or both again. And so I don't know, I guess is my answer. Off the top of my head, I'm not really sure, but I think, because whatever word we use is going to probably end up coming to have the connotation of intent. And I think, that, so what we have to change is our understanding of how our actions relate to our intentions and our motivations. And I suppose partly why I wrote the book,
Yeah, I suppose the other issue is that in using that term, we're assuming that some of us are bias free and some of us have it, right? So that's the other kind of a.
Well, everybody has,
and everyone has,
And also, I would just say one other thing is that which I think is really important, and that is, sometimes people are prejudicial to other people, and they mean it, and they're doing it with intent. And sometimes people are prejudicial and they don't mean it, and they don't even realize they're doing it. And I think that's important to remember. And I think there are some really poignant examples of that in the most high profile cases that we've seen and dealt with over the last couple of years. But again, I think to really dig into it, it requires a much longer time than we have today.
Yeah. Hey, so thank you so much for your generous time and thoughts and ideas. What's next for you? Are you going to work on another book anytime soon? I'm sure you're busy promoting this one, which has been a great success and has all the accolades people are going to see when I reference when I link to the website. But what's next?
Well, I am still promoting this book, and I'm really hoping that this book it's finding its ways into the hands of people who, work with refugees, or who, with children, or who work with, gang members who are, pulling their lives together and going to college. And, so I want to make sure that the people who can use this information really have it available to them. But I'm also I have been working on the side on an academic book, a scientific book for MIT Press with Barb Finley, the neuroscientist Barb Finley, on evolutionary and developmental neuroscience basis of affect and motivation and emotion. It's really what we're doing is we're going all the way back to the dawn of vertebrates to try to build a story that it will be useful for understanding a whole range of phenomena like motivation, emotion, affect, attention, but maybe in a somewhat different way than is currently the case. So that's really fun because I'm learning embryology, and I'm learning, Barb is like, she's just brilliant, and she knows almost, I don't know, I think of her as somebody who knows she knows something about everything, so when it comes to the brain. So she's just a miracle, really.
Well, if that's coming from you, I'm sure it's true and not an exaggerated statement. So thanks again, Lisa. We'll share this with everyone. I'm sure people will find it fascinating, and good luck promoting the book and with all your work. And thank you again for making time. Yeah.
Oh, it's my pleasure. This was really fun. Thank you.
Thank you.